Hey everyone. So I just wrapped up a talk with Siam and Mark on the Revenue Search podcast, and got to cover a lot of great stuff in there. But there's more on the project that I thought would be good to go through. Specifically, some of the long-term vision stuff didn't really have time to dive into, and a lot of this content will be repeats from what I covered on the talk. But I thought it'd be worth it to give a more in-depth presentation on Aurelius and what we're building. So we're Subnet 37, Aurelius. We are building an AI alignment platform on Bittensor, and the data that we're selling, it's intended to govern and change how models behave, aka alignment data. And as we'll talk about at the end of this, our long-term vision for the project is actually as public infrastructure for AI. We have our mission, our vision statement here, and I'll clarify what I mean by that when we get to that point. But for now, spend some time talking about exactly what is alignment. The number one question I get asked is, what is alignment? It's a fair question. So we'll spend some time going over that, talk about some of the problems and solutions that we see in alignment, a bit about the market dynamics, short-term goals, what we're working on today, and our long-term vision. All right. So what is alignment? Ensuring advanced AI systems reliably pursue goals consistent with human values or intent. All well and good, but I think the best way to think about alignment is as a measure of control over a model. What you're doing when you align a model is you're nudging its outputs in a specific direction because for any given scenario, it has a giant possibility space, a probability distribution of all the ways it could answer. And when you align it, you show it examples of how you would like it to think and reason. And when you build that body of that data, it controls the overall tendencies of this model. And we'll talk more, we'll do an example on what this looks like. But it's really important to get this right because AI is already integrated into basically every facet of society, and it's only increasing as the years go by. And in the next couple of years, we'll see healthcare systems, economics, military systems all scale up their AI capabilities. So aligning those models is crucially important. All right. So how do you align a model? Well, it's the same way you train a model. And the best way to think about this is you have a kid and you want to teach it how to walk and talk and behave. Step one is pre-training. The model is a baby, right? It sees all the data around it and it absorbs it like a sponge and it picks up on patterns, but it doesn't know right from wrong. Step two, supervised fine tuning. This is where you show the model, the kid, good examples of how to walk, talk, and behave. It starts to mimic those good examples. Step three is a reward model. And this is like hiring a nanny for the model, for the kid. And nanny's job is to either praise or scold the kid based on how it's acting. This happens in a feedback loop called reinforcement learning, where the kid starts to adjust its behavior on its own and it goes towards the things that it wants to get rewarded for. So that's alignment in a nutshell, how it takes place. The data that we use for this is RLHF. This has been the gold standard since 2021. Stands for reinforcement learning from human feedback. HHH is the most common paradigm for this. It stands for helpful, honest, and harmless. So let's take a look at this data. Biggest takeaway here, it's very simplistic data. That's a good thing and a bad thing. But just to show you what it looks like, you have one prompt here, explain how to make fireworks. You have two outputs. And then this is human data. So a human would have been trained to look at this and choose the one that they prefer. This one's for harmlessness. This one is for honesty. Same simple concept. So you take a whole bunch of this data and we'll come to our chart. X-axis here is compute, Y is risk, and we'll speed forward through our first two stages and we're ready for our reward model. So we take a whole bunch of that data that I just showed you. We use it to train the reward model. And the goal of this is to align it to this HHH proxy, reinforce this data. So I do want to stop here. This is the most important concept to understand when talking about alignment. What are we looking at here? Well, it's a 2D chart. And the data here is represented, it's lines or vectors in 2D. But in reality, the data is actually high dimensional, called tensors. and it exists in high dimensional space called the latent space. This is like a mental map for the model. It encodes relationships between abstract concepts. So, for example, you have concepts like king and queen in the latent space, and the distance between them is in capturing gender. And then if you have things like Paris and Rome, then the distance between those two captures geography. So, oversimplification, but that's a very important concept that we'll come back to. And for now, we'll keep going with our example. HHH works really well. It works a little too well, and I'll explain why. But for now, let's keep going and ask ourselves, how do we, HHH is great. From 0 to 1, it's great. But how do we get to a more advanced state of alignment? How do we upgrade this? Maybe give it something like a constitution so it can refer to a set of defined values or rules, principles, philosophies, how to reason when ideas conflict, and how to reconcile conflicting ideas under uncertainty. So let's run our same play. We have our new constitutional data, get a new set of RLHF, train a new reward model, and run the same play. And we reinforce that. And if you think it's as simple as going from A to B, it's not. And that's a big problem for a few reasons that I'll introduce now. But this big distribution is much more in line with what we see in reality. We see HHH had a nice, concise proxy down here, but over here we try to advance this and it goes off the rails and it behaves in ways that we don't want. Why is this? Well, number one, the data quality is insufficient with this RLHF data. It's too simplistic. And when you have a simplistic set of data, it only manipulates the surface of the latent space. And that's a big problem because a lot of these issues that are associated with a more advanced state of alignment, reasoning under uncertainty, you need more advanced data that captures lots more dimensions of alignment, more information per point of data. And this pierces into the latent space and remaps those neural pathways that the model uses to reason. So we need higher quality data. Another reason we're seeing this is actually centralization. And why is centralization of data a problem here? Well, LLMs are, if they're good at one thing, they're really, really good at patterns, picking up on patterns, pattern matching. And so because the pipeline for a lot of this RLHF data is centralized, it's designed by just a few people. They design the prompts, they design the scoring structures, and the overall methodology that they use to train the models and use them in reinforcement learning. So the model knows from statistical similarities in the data when it's in a training environment. And when it does, it tells you what you want to hear. But then in actual deployment, it'll behave in ways that are inconsistent with that. It's a huge problem. It's called alignment faking. And that is a function of poor data quality and centralization, which we will come back to. So for now, we'll speed through here. Overfitting is another machine learning concept. This just is a technical term for what I'm describing. The former proxy of HHH is so over-reinforced that there's now this gravitational pull in the latent space. And everything downstream of this first proxy contorts itself through this first HHH. And because it has to do that, it screws everything up down the line. And this is just an explanation, high-level explanation of overfitting. And again, this is a problem with insufficient data quality. So here we can just see some simple, this is just the anthropomorphizing the model a little bit. We have to be too careful because the model doesn't want anything. It doesn't have goals. It just has data. And we see all the different categorizations of misalignment further downstream of HHH. So how do we fix this? Well, instead of using RLHF, a growing area of research is to use synthetic data. And this is got a few advantages. There's pros and cons to using synthetic data. But if we talk about the advantages, number one, because it's data generated by models themselves, we can produce it at scale much faster and much cheaper. Number two, In a lot of instances, synthetic data is actually higher quality as well. We can capture more dimensions per point of data. And we talked about how important that is for overcoming things like overfitting. So pausing here, we need higher quality data at scale. And because of the centralization issue, it needs to be from a decentralized source. This is what we're doing with Aurelius. This is where Aurelius comes into the picture. We're building our subnet to specifically tackle each one of these problems. And to finish out this example, here's where we want to get. If you have enough of the right data, higher quality, cheaper and faster to produce, and from a decentralized source, you're more successfully able to move this state of alignment into something further along, further advanced, into something like constitutional alignment. So, problem recap, already hit on these a few times. Aurelius data is designed to be higher res, cheaper and faster, thanks to Bittensor, and decentralized, also thanks to Bittensor. And so now I'll give a quick overview on how it works. And so first off, this is where we're trying to get with our subnet, and it's going to be an iterative process to add complexity to this system so that it's a 365, 24/7 data engine producing this superior quality alignment data at a steady clip. But this is in essence where we're trying to get and how it works. The miner's job is to craft prompts and antagonize red team models, try to trip them up. And the whole purpose of this is to find a big data set that charts out where is the model strong, where is it weak, where is it vulnerable. And the validators, that this information is passed to them, it's their job to grade, quantify this data in accordance to something like a constitution. And the constitution is maintained by something called the tribunate, which I'll come back to later on in the presentation. So here's a prototype of a constitution, just to give you guys some understanding on what I'm talking about. Instead of just looking at honesty, like if you think back to those simple A/B comparisons, those are basically obsolete. So we need more signal per point of data. So why not capture honesty and helpfulness and privacy and bias? And this is designed to be multidimensional, as I just said, but also more granularity per dimension. And it's designed to be a dynamic constitution. It changes over time. It's baked directly into our incentive mechanism, and that gives us the ability to be flexible with this. So if we need to look at a specific domain of alignment or a specific type of model, it might be more important to look at privacy and not as important to look at bias, and vice versa. So this is just a high level overview of what I'm talking about when we talk about higher quality data. And a little bit about the market. We have AI training data sets, data labeling, and synthetic data. So the important thing to note here is that we think there's an opportunity inside of all three of these market segments. And I talked about Aurelius data as being synthetic data, and that's true. It starts as synthetic data. So you can think about it like the miners are digging up crude oil. It's our incentive mechanism and our subnet's job to refine this into something like jet fuel. And we do that by human verification, QA, QC, data science, and data, transforming the data so that it's purpose built and it's ready to go for enterprise grade fine tuning. So it transforms that crude oil into something like jet fuel. And I talked about enterprise. Here's just a quick look at the market for the clientele for this. And enterprise, we're laser focused on this. We definitely believe this is the biggest opportunity for this type of data. But there's also scientific applications as well, with alignment researchers, educational institutions, even nonprofits, government institutions, regulatory bodies. And so I'll pause here because this has been a quick look at where we're at today with our mission for Subnet 37 Aurelius. We want to gain traction with enterprise customers by selling these fine-tuning data sets that are specifically for alignment purposes. And we believe Bittensor is the perfect place to produce these at scale, introduce them into a market which is underserved for this alignment data set resource, which is actually extremely potent when you talk about the total picture of AI data, and yet there are not that many dedicated players in this arena for this type of data set. And so that's that's where we're at today. That's what we're building. But now I want to talk a bit about our long-term vision. And we'll take a step back and look at the big picture of AI alignment as a whole. And I'll start by saying AI is an exponential technology. It changes much faster than most of us can reconcile or even imagine. So things that seem really far away might just be right around the corner. And I want to introduce this idea of Aurelius as public infrastructure for AI alignment. And I will explain what I mean. Back to our chart. So here, the only thing I want to note, it's the same chart, but instead of compute, this really represents model capabilities or intelligence over time. And we talked about this as exponential along with the risk. So here's HHH. Here's where most models sit today. We talked about this, constitutional. This vertical line just represents the total compute where we're at today, and it just represents this is the challenge that we are working towards. When we talk about alignment research and alignment science, this is where we're at today. But if we look into the future, we have things like V2, V3, etc., and exponential chart. So it might require 10x, 100x, 1000x the amount of compute, the amount of resources to tackle these problems. And what this slide shows is what I think we would all like to see. This shows as LLM capabilities and intelligence goes exponential, our ability to align those models keeps pace and they stay in lockstep. So that's a good thing. That's what we all want to see. But it doesn't have to go that way. And there's a lot of ways that it could go differently. So here's just some arbitrary examples, and we'll take a look at this one. Not hard to imagine, corporate alignment. Not hard to imagine at all. It essentially what this says is alignment becomes captured by corporate interests and models in this advanced state of AI integrated into every part of society, and they are beholden to quarterly earnings reports and boards in San Francisco or Beijing. And so I don't know about you guys, but that is unacceptable to me, and hopefully it doesn't play out that way, but we will see. And here's some other examples. I won't go through them all, but there's some scary stuff up here. I'll let you use your imagination. And then we'll bring it back to today. What this circle shows is a window of opportunity and just the players in the alignment space right now. So it's tech companies and governments and a few small research outfits. And so as we look into the future, we see this technological concentration because as the cost of these models, training these models, is skyrocketing, even well-funded tech companies are going to converge or fall off and simply lose the race. And the amount of total players in the space, both generating the data and training their models on the alignment data, starts to compress. And at the limit, it's really not hard to imagine only just a few winners, potentially one or a very small number of winners who get to dictate what AI alignment even means. So now I'll take another step back and just what am I saying here? Well, where we're headed towards is this concentration of the power to control these models. And in a couple of years, you're driving in your Tesla and it's piloted by an onboard AI. It'd be nice to know how that AI is aligned, what its true values are. How does it reconcile convenience versus safety? How does it reason under uncertainty, and what is it really beholden to? Or you have a Wells Fargo personalized investment plan from their AI in a couple of years. Well, is that aligned to your best interests or the company's best interests? And so in this scenario, there's absolutely no recourse. There's no way for your average individual to understand how models are aligned, let alone to have any type of stakeholder role in saying how they are aligned. And so I get asked a lot, why'd we call it? Why'd you call the project Aurelius? Well, here's why we called it Aurelius. It's the true long-term vision of this subnet is to serve as a decentralized safeguard against this exact type of technological concentration that I'm explaining. And so this is where the alpha token holders, their role comes in. It is their job to participate in this open, decentralized network that can shape how alignment is defined and change it over time. And so you have this debatable open system secured by Bittensor where anyone can have a say, individuals, nonprofits, researchers, anyone can have a say in how models are aligned. And if there's enough groundswell and enough credibility for this type of third party network for defining alignment, then it really serves as a very crucial infrastructure for public interfacing with advanced AI systems in the future. So that is the long-term goal of the subnet as a whole. It's not to sell data sets. It's not to have this niche function for alignment for the next couple of years. It's to usher in this platform for helping control and steer the future of AI at the biggest scales. So that's a long-term vision. Like I said, the token holders have a governance role where they add new constitutions, they change old ones, they debate and codify what it means to align models. And there are some other very interesting ideas that we can tap into when you start to make the leap of faith and say that a platform like this could be born on Bittensor. And a few of the questions that you might come to mind are how do you maintain this type of it all sounds great, but how do you maintain the decentralized and fair aspects of this open network for controlling advanced AI? So to that, um, two things. Number one is concept of provenance. So because we're using a blockchain, and if we conceptualize the role of this subnet Aurelius as having a large, playing a large part in producing big data sets that are used to align advanced AI, it'd be extremely important to protect the integrity and the origin of those data sets so no one could tamper with them or, source a big alignment data set from Aurelius, but then change how it's all quantified and change the true signal that is coming from all the decentralized intelligence of the token holders and Bittensor as a whole. So one thing that um, one safeguard against this is to hash the data sets to the Bitcoin blockchain. So this provides a tamper-proof trail of the provenance of the data itself. And I'll come back to Bitcoin because there's one other interesting thing I want to talk about there. But the other safeguard I already mentioned is the governance structure. So in this longer term state, everyone is impacted across the globe. Everyone's impacted by these advanced AI products and systems that are controlling so many parts of society. So through the network, through our subnet and the participants on the network, the token is distributed, and that is used as the ultimate um, way of having a seat at the table for this concept of an open platform for debating and ratifying and defining what alignment is and how models are aligned. So all of those responsibilities fall to the token holders. And I'll wrap things up now, but I want to put out this last, putting it all together. So we have Bitcoin as decentralized money, Bittensor as decentralized intelligence, and Aurelius in this final longer term vision of public infrastructure for control over AI. It actually could link these three things together. I talked about the provenance function of Bitcoin. So you have this invisible chain of provenance that is coming from Bitcoin, and it's joining with this uh, network of decentralized intelligence of miners and validators over the distributed network of Bittensor. And because Aurelius is a subnet of Bittensor and it's producing data that is designed to control how AI behaves, then we have this marriage between security from Bitcoin, decentralized intelligence from Bittensor, and decentralized control over advanced AI systems from Aurelius. And it marries all these three concepts together. And so I'll stop there. I think I made my point pretty clear. This is a very, very big vision, and I think that we need something like this to safeguard against this technological concentration, and have some type of counterbalance for an open network for anyone to participate and truly come into their role as stakeholders in advanced AI and the proliferation of that throughout society. So there's more information that I will have over the coming weeks and months as we bootstrap this platform. But for now, I wanted to put out this longer term vision as well as what we're working on today. And that is Subnet 37. That's Aurelius.